오늘 바쁘신 중에도 불구하고 행사에 참여해 주신 회원 여러분과 내외 개빈 여러분께 환영의 인사와 깊은 감사의 말씀을 드립니다. 저는 사회를 맡은 학술발표대회 부위원장 김현수 교수입니다. 오늘 이 자리는 회원 여러분과 함께 건축 문화와 건축 산업의 미래 비전을 제시하고 건축인 모두의 교류와 화합을 도모하기 위한 자리입니다. 이러한 자리에 건축계의 많은 선후배, 동료분들과 함께 할 수 있어서 대단히 영광스럽게 생각합니다. 그럼 오늘의 첫 번째 순서인 학술발표대회 개최를 기념하기 위한 특별 강연을 시작하겠습니다. 먼저 강연자 양력 소개가 있겠습니다. 카네바코 요시하루 대표님은 도쿄 공업대 건축학과를 졸업하시고 동대학원에서 박사를 취득하셨습니다. 현재 카네바코구조설계사무소 대표이며 도쿄 공업대 특정 교수로 활동하고 계시며 일본 건축구조기술자협회 회장 등을 역임하셨습니다. 신축 건축물 구조 설계로 일본 건축학회 작품상, 일본 토목학회 작품상을 비롯하여 다수의 내진 관련 건축상을 받으셨으며 2024년에는 박물관 설계 등 3개의 구조 설계가 각각 65회 BCS상으로 선정되어 수상을 하셨습니다. 저서로는 디테일러부터 생각하는 구조 디자인을 비롯하여 다수의 도서를 출판하셨고 많은 논문 연구를 발표하시는 등 구조 설계자로뿐만 아니라 연구자로서도 활동하고 계십니다. 오늘 특별 강연은 구조 디자인의 역할과 가능성이라는 주제로 해주시겠습니다. 자, 그럼 카네바코 요시하루 대표님을 단상으로 모시겠습니다. 나오실 때 큰 환영의 박수 부탁드리겠습니다.
안녕하세요. Thank you for introduction and inviting me to this conference. I'm Yoshiharu Kaneboko. I have a structural design office in Tokyo, and I teach structural design practice in a university. Today, I talk about the role and the possibility of structural design. I designed many architectures with many architects. This is a Korean embassy in Japan. I worked as a structural engineer with Chanjo Architects in Korean architectural office. Now I start presentation. What is a structural design and how to do structural design? I think about relationship between architectural design and structural design. A space, form, texture created by architectural design. On the other hand, frame and materials are determined with obeying dynamics by structural design. So to speak, architectural design is image field and structural design is real field. It is important that both fields must have close relationships. I think about building structure. Structure is free. Structure has infinite possibility. Any building can be realized structurally. Both buildings are quite challenging and exciting architecture. But structural rule and dynamic theories, honesty, it is very important. A reckless architectural design makes non-efficient structure. These two structures, right side, have complicated stress flow and are non-efficient. Sometimes non-efficient structure should not be realized for economic reason. So structural design is needed efficiency and considering cost and budget. I say the answer of the structural, what is structural design? Structural design is making efficient frame with sufficient suitable materials to satisfy architectural image. I think so. So now I introduce several projects which I did structural design in various architects. First project, Atrium in Kyoto Station. Kyoto is the ancient capital of Japan. This project commemorates the 1,200 years anniversary of being established as an ancient capital. The architect is Yoshihara, who was selected by an international design competition. This building is a large station complex which has station facility, hotel, department store, and theater. It includes 60 floors and 3 basement floors. Total area is 230,000 square meters. In the center of the building, here, there is a concourse which is covered with glass roof and wall. This is an image drawing of the atrium, which was drawn by the architect for the competition. This is an image, and this is a concourse with a roof and wall covered with glass. There is an entrance gate at the left side, and at the right side there is a plaza. The architect wanted to make the spatial structure, which has delicate grid and composed with thin steel members. An observatory passageway named Skyway is hanging from the roof at the height of 42 meters height. This is a real structure. The atrium's overall dimension are 150 meters as length, 30 meters width, and 50 meters height. This is a very short grid, and the member must be small as possible. So the distance of the grid is 1.44 meter, very short grid. So the member use this structure is box section members 100 millimeter by 100 millimeters. The right side, the right figure is skyway. People who can see the city from here. This is a view from the upper position. At the right side, the steel structure of the wall is supported by this combined frames at the pitch of 20 meters. People go through this, between these combined frames from the concourse to the plaza. At the left side, there is a building, so the roof is supported continuously. And there is a large stair from concourse to the top level, rooftop levels. This is a section of structure. The element from the structure is a large bolt, small bolt, and plain combination. About this section, you might understand this is a 30-meter span, one-way truss structure. The truss supported 3 levels, here, here, and here. This is a plan and elevation of steel structure. Red marks is supported point of steel frames. The arrangement of planary longitudinal direction is only horizontal member and vertical member, not diagonal member, transparent, make transparency. But near the support, the stress transform to the support, I arranged another lattice member here. So this is made like truss structures, but the member is vertical and horizontal member is 100 millimeters, 100 millimeters. And the earthquake load, wall against wall is resisted to make several lattice member like this. And the structure of the atrium was firmly fixed to the building structure. This occurs a special problem. If the structure of the atrium is too stiff, it acts wall bracing structure to resist building earthquake force. Otherwise, if the structure is too soft, it lacks strength and against its own seismic load. So first time I arranged a lattice member like this, but it's too strong, too stiff. So finally, I use arrange a type of lattice member to optimization horizontal stiffness. And this is a joint system. As the pitch of grid is very short, if we use a special shape of joint, the structure would be too noisy. So two types of joint are used. One type is here. The members welded directly at this point. And the another connection is used cast steel joint. The cast steel joint used at the corner curved zone and near the support zone. It's another lattice member connected to here, so it's a very high strength occurred this connection. So I need cast joint. This is a front view of steel structure. We feel thin beam members connected directly, no joint shape. Our next project is a large glass architecture. The architect is Tadao Ando. The building site is a sloping hill or at the base of the mountain. There are sphere-shaped glass roof, a concrete stair, and a hothouse is under the glass roof. There are several observation rooms under this concrete stair. The distance from here to here is 70 meters. This is an architectural drawing in basic design phase from the architect office. The image of the architecture is a thin glass membrane covered on the slope. The roof shape is a cut part of a sphere by 3 lines. And there is a hothouse for butterflies under the glass roof partially, this part. This drawing shows form and image, but didn't show structural element. On structural design, I needed to determine a grid of roof and support condition, consider the hothouse, and member section and connection. I thought it was important how elegant the perimeter zone in this structure. So this is a method making the grid. Cut the sphere by 3 plane rotating. And this is 3 lines. The cross point of 3 lines coincident in the center parts. but it's not coincident. Peripheral, like this. So I arranged the line, and the three lines coincident, same point, like this. After that, a three-dimensional structure model were made in my office by my staff. The length grid about 4 meters, and the shape of triangle almost similar. This is a view of the model from side position. In this stage, I adjust the roof height to be a little higher. This is an architectural sketch. Because the height of the architecture image is too low, so the stress of member is bigger, and the size of member bigger. I want to the size of member possible small, so arranged the height is higher. Next, I research about the support section, 4 types. This type support is only 3 corners, so this is very dynamic structures. But in this architecture, there is a butterfly's hothouse here, so several columns allowed to put here. And type C, as compared, V-shaped columns, preferred zone, placed like here. And type D is combined type B and type C. I researched the buckling coefficient by elastic buckling analysis about vertical load. And this number is a coefficient of buckling strength safety. The higher the number, the buckling resist capacity is higher, and the size of member is smaller. So the big number is a good condition for me. Type B is not efficient because partially a long span zone consists. And type C and type D is efficient. I choose type D. I propose the architect the structure grid and the support condition. He accepted my proposal and made design a V-shape architecture. This is an architecture model. And the member size was minimized by this structural system. The inner member is steel pipe with 267 millimeter diameters. And this is a connection. 6 pipe members are gathered at one connection. So it's a visible structure. So the connection must be beautiful. Cast steel joints were used, and pipe members were welded to joint. The glasses are placed under the steel structure. Glasses are fixed directly structural member by DPG, dot point glazing. The size of glass is 2 meters. There is not a secondary structure to support glass. It is very simple and transparency roof. Next project is a gymnasium of a junior high school in a local city, which was designed by Ando. It is wooden architecture. Wooden architectures have been increased in Japan recently, considering environmental problem as reducing carbon dioxide. The upper figure shows the whole of this school's figures. There are 3 buildings: a schoolhouse, a passage, and the gymnasium. Gymnasium, the plan shape is oval, and size is 67 meter by 43 meter. The architect gave me this drawing only this drawing. And he speak. The roof was imaged wooden membrane structure using diagonal grid, and the wall was imaged wooden diagonal structure. I heard his word, this drawing made by me. And this is a wooden arcade in Aomori Contemporary Art Center, which I did structural design in 2001. It was completed just before the beginning of design of the previous gymnasium. So I think the architect might image like this. This is wooden membrane structure, but it's a very small structure, 9-meter span. These two structures are different away. Aomori structure and arch structure, high-rise depths, and in the ground, tie beam placed, and thrust force is resisted. But a previous gymnasium is low-rise arch, and thrust is bigger. And it was supported by weak wooden structure, so the thrust arch was not resisted. So I researched the structural form and the member and made 3 types of structural model. First model, it is only a wooden member used. So it's not arch structure, so it is truss structure. It's not field membrane structure. And second model, the upper chord is wooden beam, and the lower chord is tension cables. A tension cable is very thin members. I think it might be a field of membrane wooden structure. And third model is diagonal wooden beam and tension cables. I show 3 models to the architect, and of course, this type was selected. After that, I arranged the structural system a little. I arranged the angle of beams like this to decrease the cross point. The cross point is difficult for wooden structure, difficult and much cost. So the cross point decreases, and the angle of direction of tension cable is the same arrangement of upper wooden beams. This is the interior view. The structure is a combination wood and steel. But when people go into this gymnasium, they felt a space made by wooden membrane structure, I think. This is a side view of the interior. This is a column, and this is a beam of roof. The angle is almost same, and those elements felt continuously. At the end of roof beam was used steel joint. The tension cable was connected to the joint. The connection member of roof beam and wooden column were used steel pipe. The next project is Hiroshima Baseball Stadium. The architect is Mitsuru Senda. This stadium included 30,000 people and is a unique composition. The future of this stadium is a symmetrical shape, like this, and having variety forms. And the period of design and construction was not enough. The design was completed in 9 months, and the construction was completed 16 months. And the allowable budget is very severe. This is a circular road named concourse around low seat, and there is an arch structure which supports the upper seat over the concourse. There are several different shaped overhang structure for balcony seat. This is a party zone. People have a delightful time watching the game and having a party. The most valuable seat in the two seats at the back zone of the home base. This is the VIP zone, which has a private special room and a private separate balcony like this. And under level, this is a sports writer's seat. The ceiling height is very low. These are the upper stand for supporters as independent structure at the outer field. This is a structure system. I think, how did I make the variety structure for this architecture? The building includes standard parts and individual parts. There are expansion joints here. The front stand is reinforced concrete, side poured concrete. It is a normal, easy structure. And our higher stand is composite structure. The lower part and the concourse is reinforced concrete, side poured concrete. The span is 13 meters, so the post-stress concrete was used. As the upper structure, precast concrete was used. When lower part constructed in the site, the PC members upper zone fabricated in the factory simultaneously. And after the lower part completed, the upper zone constructed immediately. And the individual part were used with steel frames. It is useful to make various shape frames. This shows a diagram of combination about PC frames and steel frames. Three types of PC frames were prepared, and steel frames, several types of steel frames added these PC frames, outer zone and hanging floor and roof. These are precast concrete frames for standard parts. The frames are a little complicated structure, but were easy to construct it by using precast concrete. The floors and step seat are made with PC slabs, WT-shaped PC slab and L-shaped PC slab were used. These are hanging floors at the back stand. The steel frames are hanged from the PC frames like this. The upper stand at the outer field were planning to use PC structure also. But the PC frame were placed radially like this. But the plan shape of the this stand not coincident end zone. End zone, the center is wanted to wider. So I use steel frames. This part, it is easy to make irregular shape of steel frames. This is the left stand view and the structure. The future of the stand is felt sense of wider and togetherness. At the end part, the steel frame is supported steel columns. These photos are scenery of the opening of this stadium, 2009. People enjoy a game and the stadium. The next project is a Verb Museum of Fukui Prefecture. Architect is Hiroshi Naito. It is located on a site rich in nature near the large lake. What is Verb? Verb is an accumulated mud at the bottom of the lake, which shows the state of climate condition in past time like this. A thickness of layer per year is 0.7 millimeters. The mud has been accumulated for about 70,000 years in this Suigetsu Lake. The total thickness of mud is 49 meters. This phenomenon is rare and precious, which only a few examples in the world. The building is used for exhibition purpose, so the shape of the building is belt shape, which has 9.6 meter width and 76 meter length. And material of the roof is used to wood of the local area requested by the client. And the second floor is used for exhibition space. There is RCO in the center, eccentrically placed in center, which divided space as 6.4 meter and 33.2 meter. And the first floor is used for lobby and piloty because of the floating hazard on this side. And those structure is unified with landscape. Considering architectural image, I think issue of structure design. So this structure, first scale is different first story, between first story and second story. First story has a big scale, as civil engineering scale, and the second floor, a small scale, architectural scale. And I must consider a seismic design of this complex structure. A secondary relationship RCO and roof structure. And the site is very snow region, very heavy snow region. I have to consider about heavy snow road depth as 1.8 meter. This model was shown by architecture office at the first meeting. This is unsymmetrical structure. So the structure occurred horizontal movement by snow road. So it is needed to horizontal stiffness. But because wooden structure is difficult to make a rigid frame, some diagonal members were selected. I talked to the architect. I researched several types of structure. These types are placing any diagonal member or placing tie beams. Type F is a steel column embedded in RC wall to resist horizontal stress. This is a moment diagram of each type. Type B is most efficient structure because there is a tie beams. But tie beams disturb space, I think. So type D and F is available for architectural design. This is model type D and F made in my office. I discussed the architect with these models. After discussion with the architect, combined system type D and F was decided. This is a model made by architect office. But this model has another problem. It's a longitudinal direction problems about seismic load. Some diagonal members needed to transfer earthquake load of the roof to the RC wall. The drawing is like this. We considered it is very complicated structure, so we considered diagonal member were used with steel member or not. I and the architect discussed again and decided to change structural system. Previous system like this, RC wall and wooden roof and wooden support members. And improvement member, steel members arranged these parts between wooden members and RC wall. Steel members can be smaller than wood members. It is strong materials. The image of the architecture, this is a model with diagonal member with steel. And the image of the architecture changed. The large wooden structure is supported by small, thin steel members. And this is a final model by architect office. Mechanical equipment are shown here. The diagram shows structural system. The wooden roof is combined glulam beam and plywood panel, and steel members, a beam, a diagonal member, and columns. It's a very small members. And RC wall and RC slab supported precast concrete, PC pressless beam. This is the process of design. Firstly, a model made by architect office was shown to me. Next, revised model were made by both office. And the model is made after the discussion. And the changing structure concept, this model was made by architect office. This is a final model made by architect office, and my office made final models. The left side is architecture office model, and the right side, structural office model. The structural office model is only white members, but the architecture office model is very colorful. It is a difference, architect and engineer. This is an interior view of the exhibition room. A wooden structure is a simple arrangement, very simple arrangement, and very easy to construction, and of course, very cheap structure, cheaper structure. Complicated details are used only steel members. This is a complete exhibition space of the second floor. The exhibition above is shown the left side, left space and right space. There are several panels and several models. This is the outer view of the building. The architect unified landscape, and this is a pilotis. A beautiful finished concrete appeared. The architecture unified landscape. Our last project is a public library in a local big city, Kanazawa. The architect is Mitsuru Senda. This is a floor plan, and this is the outer view of the building. The plan of the building was rectangle in shape, 67 meter by 76 meter, and has 4 floors and 1 basement floors. This is the interior of the building. There is a large wooden room, great hall through the ground floor to the third floor, which is continuously connected with step floors and slope, and has circular grid. A bridge across the room was planned in the center of the zone. The center of the roof is raised up in an elliptical shape. The planetary size of the elliptical dome is 42 meter by 34 meter. The dome is single layer lamellar dome supported by steel columns. And there is a flat roof above domes. This figure shows the structural section of the building. A base isolation structure was adopted to enhance seismic safety and to maintain its function as a library after an earthquake. The basement floor was used closed stacks, and it is made with a rigid reinforced concrete structure. And the beam of first floor are steel beam and SRC beams. The upper floor is a steel rigid frame, and the periphery zone, CFT, confined steel pipe columns are used. The structure grid is different above ground and basement. Left figure, basement floor plan, and the right figure, upper floors plan. The grid is different. Basement are used closed stacks, so grid is normally, but the upper floor, elliptical grid. The difference of the grid is important and very difficult problem of this structural design. The above floor, step floors and slopes. This is construction scenery. And we use this irregular shape step condition beams are used. And the roof design. Various types of structure of the roof was considered. I and the architect discussed about more 20 ideas discussed. This is the main ideas. This idea is used arch structure, arch supported bridge and roof. And this is at the center zone, big column, tree-like columns arranged and support the roof. And this is a beam string structure, and this is a beam string structure supported slant columns. A beam string structure don't cause horizontal reaction, so it is easy to be supported by under structure. But the center of the roof convex downward. And the architect said sufficient height in the center of the room was required, like this. So dome or arch structure was studied. The final structure idea is shown the right figures. This is an irregular single-layer lamellar dome. The member arranged diagonally in the elliptical plan like this. This grid is not existing circumferential members like these members don't exist. If we use these members, it's a triangle grid like previous presentation, Gunma, glass roof. It's a dome structure, but it's not dome structure. So it's a collection of arch structure. The roof structure consists of arch and flat structure above it. And the post member placed at the intersection of the diamond shape of grid and connection, both structure. And the arch structure occurred thrust horizontal stresses. The axial force transfer like this, and this is a slant column. So another slant column placed the opposite side of the column, and this stress transfer the slab around flat slab. And the ring-like resistance effect of the slab arch thrust resistance. The lattice member are used with combined angle section. Angle section combined like this. This is very special combination of arch members. The size of angle section member is 150 meter by 150 meters. So this combination, the member look like the box section members. And the connection is important. There is no connection of this fault. In construction, the end of angle members are chipped on one side and welded plates. And the post member, a gusset plate welded connected post members and gusset plate and end plate of L angles connected a bolt. And after bolt fastening, these cover plates welded. After compression, the members distinct box shaped with emphasized edges. A distinctive feature of laminar dome structure was realized by using combination of angle members. On New Year's this year, somebody knows that North Peninsula, at the North Peninsula, a big earthquake, a mega earthquake has occurred. This site is near the North Peninsula. But this building was no damage at all because of its seismic isolation systems. I think about a relationship between architectural design and structural design again. In a good relationship, architecture think structure and structural engineer think about architect. It is a bad relationship. Architect and engineer think about only one part. The transfer of information is one direction. An architect says, I want to make this image architecture. And the structural engineer puts the data to computer program. Yes or no? It is not good relationship. I think in order to excellent architecture, we structural engineer think about architecture and architect think about structure. This is my presentation. Thank you for your attention. 감사합니다.
네, 뜻깊은 강연을 해주신 카네바코 요시하루 대표님께 감사드립니다. 오늘 강연을 기념하여 바로 기념 촬영을 가질 예정이오니 카네바코 요시하루 교수님께서는 잠시 자리에 계셔주시기 바라고 내빈 여러분들 잠깐 앞으로 나와주시면 감사하겠습니다.
はい.
本当にありがとうございました。 네, 바로 이어서 바쁘신 중에도 불구하고 2024년 추계학술발표대회를 축하해 주시기 위해 참석하신 내빈소개가 있겠습니다. 소개시켜 드릴 때마다 큰 박수로 환영해 주시기 바랍니다. 전 국가건축정책위원회 위원장이셨던 이상정 위원장님, 한국건설관리학회 이동은 회장님, 대한건축학회 강부성 전 회장님 참석하셨습니다. 대한건축학회 최창식 전 회장님 참석하셨습니다. 한국건축구조기술사회 김영민 회장님 참석하셨습니다. 네. 자, 그리고 오늘 특별 강연을 해주신 카네바코 요시하루 대표님 다시 한번 박수 드리겠습니다. 그리고 제41대 대한건축학회 박진철 회장님 참석하셨습니다. 이 외에도 많은 분들이 참석을 하셨는데 시간 관계상 일일이 소개를 시켜드리지 못하는 점 다시 한번 죄송하게 생각합니다. 자, 다음으로 2024년 학술발표대회의 대회장이신 대한건축학회 박진철 회장님의 인사말이 있겠습니다. 단상에 올라오실 때 큰 박수로 맞아주시기 바랍니다.
네, 감사합니다. 오늘 저희 학술대회 추계학술대회 경주에서 이렇게 개최를 하는데 또 우리 오늘 좋은 강의는 구조 디자인 쪽에 우리 요시하루 카네바코 우리 박사님 강의해 주셔서 감사드리고요. 오늘 이 특별 초청 강연을 저희 회장단의 주영규 연구 부회장님이 또 탄소중립원도 맡고 계시는데 특별히 만드셨습니다. 제가 인사말 하기 전에 주 부회장님 잠깐 오셔가지고 인사말. 네, 잠깐 나오세요. 우리 박수로 부탁드립니다.
예, 주영규입니다. 사실은 우리 특별 강연자분은 한국건축구조기술사회 회장을 하시는 정광양 전 회장님께서 좀 하면 어떠냐고 좀 말씀을 해주셨고요. 사실 오늘 초청안에도 많이 좀 후원을 해주셨습니다. 그래서 오늘 구조하고 디자인 같이 연결된 아주 좋은 강연을 해줘서 정말 감사드리고요. 제가 여기 나와서 말씀을 드려야 되는지 모르겠습니다. 하여간 오늘 귀한 강연해 주신 우리 특별 강연자께 다시 한번 감사드리고요. 오늘 저녁에 또 좋은 시간이 됐으면 좋겠습니다. 감사합니다.
저는 인사말이라 그래서 다시 한번 오늘 가을 날씨가 아주 좋습니다. 그래서 경주 대한민국의 신라의 곧 우리 옛날 수도 경주에 와서 이렇게 좋은 학술대회를 해서 아주 너무 기쁘고요. 또 많은 분들이 참석해 주셔서 감사드리고, 한 가지 우리 강연 내용에도 그렇지만 최근에 우리 구조 디자인이라 그러는데, 제가 조금 아까 우리 진상윤 전 부회장 겸 지금 현재 우리 뉴노멀 미래성장위원장이신데 9월 말에 세미나를 해서 제가 잠깐 들렸더니 디지털 설계 프로세스에 대한 걸 하시는데, 요즘 건축 설계가 그냥 설계되는 게 아니라 건축물이 초고층화 비정형 되면서 구조 기술이 되게 중요하게 작용을 한다 그래요. 그래서 BIM 학회하고 저희 건축학회하고 같이 하는데, 그런 초고층 건축물에 대한 디자인에서 구조 분야의 중요성을 제가 들었던 기억이 바로 불과 얼마 전이었는데, 오늘 또 그런 강의를 들으니까 아까도 마지막에 구조 디자인의 중요성을 말씀해 주셨고, 마지막으로는 10월 8일 날 건축의 날 저희 행사를 우리 피카 3단체가 했지만 올해는 건축학회가 주관으로 했는데, 국토부 장관 박상우 장관님이 오셔가지고 하신 말씀이 뭐라 그랬냐면 영국의 처칠 수상이 사람은 건축 공간을 만들고 또 건축 공간에서는 훌륭한 사람을 키워낸다 그럽니다. 그래서 우리 최근에 건설 분야가 건설 경기에 따라 조금 높낮이는 있지만 우리 건축은 의식주의 하나잖아요. 그래서 그 건축 공간에서 우리 어떤 공간을 만드느냐가 앞으로 더 우리 좋은 사람을 또 좋은 환경을 만들어낸다는 것을 오늘 다시 한번 기억하면서 여러분들 건강하시고 또 오늘 이렇게 많은 분들이 저희 학술대회에 참석해 주셔서 감사드립니다. 감사합니다.
네, 회장님 감사합니다. 본 학술발표대회를 통해 건축 문화와 건축 산업을 선도하는 자랑스러운 학술단체로 더욱 발전하길 기원하겠습니다. 다음은 부설기관 미래비전기획원의 아키플릭스 소개가 있겠습니다. 아키플릭스 위원장이신 이명식 교수님을 단상으로 모시겠습니다. 나오실 때 큰 박수 부탁드립니다.
갑자기 단상에 서게 됐습니다. 빠르게 마쳐야지 교류의장의 또 이 좋은 음식과 함께 화목의 그런 시간을 가질 수 있게 될 것 같습니다. 제가 갑자기 나서게 된 거는 이 건축학회에서 새롭게 시작하는 아이템이라고 할 수 있고, 그 다음에 현재 사회 변화나 미래 변화에 대응할 수 있는 그 하나의 변화가 요청이 되는 부분의 실천 항목으로서 아키플릭스라는 하두를 가지고서 지금 진행하고 있는 거를 좀 말씀을 드리면서 또 도움을 좀 요청하고자 이렇게 마이크를 들었습니다. 제가 빠르게 그 설명드리고 그리고 이해를 돕고자 하니까 한 10분만 주목해 주시면 좋을 것 같습니다. 여기 나와 있는 아키플릭스 하면 뭐냐 이렇게 많이 생각들을 하실 텐데요. 이 아키플릭스는 약자입니다. 아키텍처하고 그 다음에 넷플릭스. 여러분들 넷플릭스는 잘 아시죠? 그래서 건축에 대한 넷플릭스형 플랫폼 부분을 이번에 건축학회에서 구축하는 거를 지금 한 4개월 이상이 됐습니다. 그래서 경과 보교 겸 그 다음에 앞으로 진행하는 거에 대한 여러분들한테 공지 겸 해서 준비를 좀 했습니다. 그래서 아키플릭스 이 부분에 대한 이 축약된 단어에 대해서 좀 말씀드렸고요. 그 다음에 지금 이 아키플릭스를 시작하게 된 이유는 저희 건축학회 홈페이지를 보면 항목별로 이렇게 다양하게 컨텐츠는 있지만 검색하거나 접속하거나 구독하는 이런 분들이 거의 없습니다. 많지도 않고요. 단지 이제 행사나 아니면은 본인한테 좀 관계되는 게 있으면 잠시 접속해가지고 공지사항만 알 뿐인데, 이러한 부분을 이제 개선하는 거죠. 거기에 개선하기 위해서 어떻게 할 것이냐. 요즘 여러분들 넷플릭스 제가 예를 들었지만 유튜브 하면 오히려 건축학회 그 홈페이지 검색보다도 유튜브 검색을 더 빠르게 할 거예요. 그래서 이러한 부분에 대해서 저희가 학회가 좀 변해야 되겠다. 그리고 그 변하는 거에 대해서 뭔가 만들어 드려야 되겠다 하는 차원에서 변화를 가져왔고요. 이거 계기는 사실 박진철 그 회장님이 후보 시절에 이렇게 좀 공약사항으로 OTT 콘텐츠 서비스 제공하겠다 공약했는데 그거에 대해서 제가 끌려 들어왔습니다. 그래서 그거 실천하기 위해서 아키플릭스라는 단어를 가지고 그리고 지금 현재 구축하고 있다는 거 말씀을 좀 드리고요. 거기에서 봤었을 때 지금 여기 나와 있는 부분에 있어 가지고 좀 텍스트로 이렇게 제시를 했지만 좀 답답할 거예요. 저 역시 이렇게 발표 자료 이렇게 만드는 것 자체가 좀 답답하거든요. 간단히 말씀드리면 여러분들이 필요한 정보를 실시간으로 검색을 하는 거에 있어 가지고 인공지능이 바로 도와주면서, 그리고 대화형이라고 할 수 있는 GPT를 활용하는 게 아니고 GTP 한 차원 넘어선 옴니 방식에 의해서 여러분들이 단어만 딱딱 터치하면은 바로바로 여러분들한테 필요한 정보가 제공될 수 있는 부분으로 컨텐츠와 사용 환경과 사용자 정보에 대한 맞춤형으로 하기 위해서 이 아키플릭스를 구축하게 됐다는 부분이고요. 이 부분을 그냥 구축하기 위해서 그냥 있는 게 아니고 지금 여러 사례들이 있습니다. 유튜브 사례도 있고, 그 다음에 홈페이지 특화시키는 사례도 있고, 정보만 엄청난 빅데이터 방식으로 제공하는 것도 있고, 그 다음에 사업화하는 부분도 있고요. 그 다음에 연구 부분에 있어서 첨단의 연구들이 또 있는 그러한 정보 제공을 하고 있는 그러한 부분도 있죠. 그래서 우리 부분에 있어 가지고 이런 걸 다 사례 조사해서 옴니 총괄적으로 여러분들한테 건축뿐만이 아니고 건축 관련된 모든 부분을 사업부터 시작해서 연구 그리고 교육 부분까지 다 실시간으로 제공해 줄 수 있는 그런 환경을 우리 이제 건축학회에서 시작하면 어떠느냐 해서 아키플릭스를 발족하게 된 거고 지금 진행하고 있다는 걸 말씀을 좀 드리면서, 이게 내년 초면은 바로 여러분들한테 제공이 될 겁니다. 결국 이제 인공지능 가지고 챗 GPT 가지고 노는 게 아니고 건축학회에서 건축 놀자 이 부분을 건축학회 아키플릭스에서 제공해 드리겠다는 말씀을 드리면서 준비하는 겁니다. 결국 아키플릭스는 에이전트의 역할을 합니다. 건축 전문가의 학술단체뿐만이 아니고 여러분들이 필요한 인공지능적인 건축에 대한 모든 내용을 총괄적으로 건축 아키플릭스가 제공을 해주는 부분으로, 이게 제가 하는 얘기가 아니고 AI 기반으로 하는 지금 AI 에이전트 등장에 대한 부분 여러분 잘 아실 텐데 그걸 바로 적용해서 한다는 겁니다. 그러면 정보들을 어떻게 할 것이냐? 정보에 대한 거를 동영상, 멀티모달 이런 방식으로 편집 제작을 해야 되는데 인공지능이 해주고 있습니다. 돈도 안 들어요. 바로 첨단 기술을 적용을 해서 하겠다는 거고요. 그거를 그냥 가공만 하는 게 아니고 요즘 젊은 사람들이나 아니면 모두들 원하는 게 쇼츠예요. 1분에서 1분 30초 정도의 쇼츠 방식으로 지금 저희가 확보된 정보만 해도 5만여 건인데 그 5만여 건을 쇼츠 방식으로 인공지능에 의해서 제작, 편집, 가공까지 해서 여러분들한테 옴니 방식으로 제공하겠다는 부분이고, 이 역할은 에이전트 역할이다 이렇게 말씀드릴 수 있겠습니다. 그래서 그런 부분이 저희 건축의 장점이 디자인까지 포함되니까 멀티모달이라는 겁니다. 사진, 모델, 그 동영상, 그리고 연구 텍스트 이런 부분이 쇼츠로 제공이 되면서 만약에 거기에서 더 추가적으로 여러분들이 원한다 그러면 그 링크가 다 연결이 돼서 깊게 들어갈 수 있는 그런 부분까지도 하고 있고, 그 에이전트 역할이 지금 저희가 발족하는 아키플릭스에 담는다 이렇게 말씀을 좀 드릴 수 있겠습니다. 결국 세계 트렌드의 2025년 주요 키워드가 여기 4가지 정도인데 이 4가지 부분에 저희 학회가 그냥 가만히 있는 게 아니고 플랫폼 형식의 학회 서비스를 하겠다는 겁니다. 그리고 그 서비스가 인공지능을 접목을 해서 하겠다는 거고 세계 트렌드에, 사회 변화 트렌드에 맞추겠다는 얘기입니다. 결국 AGI, 인간의 한계를 넘어서고 전문의 영역을 넘어서는 그런 부분을 아키플릭스의 탄생으로 보여드리고자 합니다. 그래서 이미 저희가 그 편집이나 그리고 제작을 위해서 그 적용한 프로그램들이 있습니다. 그래서 AI와 건축의 융합, 그 다음에 AI 적용 사례들, 그리고 컨텐츠 융합, 그리고 거기에 대한 구축에 대한 부분까지 포함해서 아키플릭스가 있다는 말씀을 좀 드리고요. 그러면 이런 부분만 구축해서 하는 게 아니고 운영도 그냥 하는 게 아니고 사용자 맞춤형 중심으로 나가겠다는 거고, 사용자들이 또 자가적으로 가지고 있는 자료들을 올리면서 더 확장되는 그런 부분으로 나가겠다는 겁니다. 그리고 그 기술들이 같이 한꺼번에 되고 저희 건축에 관련된 모든 분야가 여기에서 같이 연결돼 가지고 나온다는 부분입니다. 그래서 기대를 좀 해주시면 좋을 것 같다고요. 그러한 부분의 사용자 측면, 컨텐츠 측면, 운영 방식의 측면, 플랫폼 구축의 측면과 운영의 측면에서 이렇게 쭉 하고 있고, 말씀드린 대로 이미 5만 건 정도의 그 데이터가 되어 있으면서 제공할 준비는 되어 있고, 또 저희 건축에 관련된 단체만 해도 상당히 많은데요. 이미 50개 단체가 들어와 있고 분야별로도 상당히 50개 분야의 커버링이 될 수 있는 쪽으로 했고요. 특히 여기에 이제 같이 기반이 되는 거는 아우릭 여러분들 건설 건축 도시 정보연구센터에서 그 가지고 있는 어마어마한 그 데이터들이 접목해서 또 들어간다는 거 좀 말씀드리고, 사실 제가 아우릭 센터장이기 때문에 또 그것도 같이 활용이 된다 이렇게 말씀을 좀 드리겠습니다. 그래서 이제 이러한 부분으로 하는데, 제가 사실 뭐 이거 홍보하기 위해서 오는 게 아니고요, 이거 혼자 만드는 게 아니거든요. 그렇다고 AI 에이전트가 만드는 거 아니고요, 여러분도 이미 갖고 있는 데이터들 어마어마하게 많을 겁니다. 그리고 뭔가 간섭 좀 하고 싶은 그러한 생각도 많이 있죠. 그런 부분이 있을 때 저희 학회에 이미 열린 폴더가 있습니다. 클라우딩 베이스에 열린 커다란 폴더가 있으니까 이 학회에다 문의만 하면은 접속해 드릴 수 있고, 그리고 모든 자료들 올릴 수 있고, 그 자료들을 쇼츠로 제공을 하면서 자기 홍보도 될 수 있고 전문적인 영역도 보여줄 수 있는 그런 방향으로 나가기 위해서 지금 준비하고 있는 운영 방안 일부를 여기다 이 게시를 해놨습니다. 그래서 이렇게 나갔었을 때 아마 여러분들 다시 자료들이, 그리고 필요한 것들이 놀면서 가져갈 수 있는 아키플릭스의 그러한 여건이니까 여러분들 관심 좀 가져주시면 좋을 것 같다는 마지막 부탁 말씀 드리면서 그냥 여기서 마치겠습니다. 네, 감사합니다.
추계학술발표대회에 참여해주신 많은 여러분들께 감사 다시 한번 드리고, 앞으로도 많은 참여와 관심을 부탁드립니다. 아까 소리를 들으셔서 아시겠지만 이 자리 뒤편에 맥주와 음식이 준비되어 있습니다. 맛있게 식사를 하시면서 환담을 나누시길 바라겠습니다. 감사합니다. 회장님께서 먼저 움직여 주셔야 다른 분들도 식사가 가능할 것 같습니다. 예.